Alright, I just saw somebody doing this one. So first off, I'm going to show what the answers were. The options for the answers. Something like that. This first one was 4 pi. This one was 16 minus 16 pi. And this one was 16 minus 4 pi. Off the bat, you should be able to tell that the correct answer is the third one, the one that the cursor is currently on. Because, note, 4 pi occurs twice, 16 minus occurs twice. And they both coincide on this one. So without even understanding what the question is, it's almost certainly the third one. It's almost certainly C, right? So this would be option A, this would be option B, this would be option C, this would be option D. So just looking at the question, at the answers, possible answers, answer's probably C. Now, what the question was, it was a diagram. So you have a square quartering a circle, and a side length to the square was 4, and it's asking the area of the square that is not taken up by the circle. Okay, so the fundamental circle constant, if you're aware of this, is pi on 4. And what this number does, pi on 4, is, this is the reason that this, and not pi, is the fundamental circle constant, because pi on 4 relates the perimeter and the area of a circle to the square that it's embedded within, that it's inscribed within. Right? So it relates both the perimeter and the area. The perimeter of the circle is pi on 4 of the perimeter of the square. Right? So if you have a circle of diameter 1, its circumference is pi, and the perimeter of the square around it is 4. So pi to 4 is the relationship. The area is exactly the same, right? If we have a circle whose area is pi, the square that surrounds it will have an area of 4. Okay? And you get this because of, if the radius is 1, the area of the whole circle is pi r squared. So the whole circle is going to have an area of pi, but that square that is surrounding it will have a side length of 2, will have a base of 2. So when you square that, you get 4. So it's pi to 4. And it's notable that we're using different size circles for both of these. The reason that you're using different size circles is to artificially make it look like pi is the fundamental circle constant when it is not. Anyway, so this is just background, what I'm saying right here. Pi on 4 is the legitimate fundamental circle constant because it does crazy cool shit. Like, it can relate both linear aspects of a circle to the square it's embedded within and area aspects, right? That's magic. Usually area and linear don't correlate, right? Because one is the square of the other. So to have this crazy value, pi on 4, relate both of them, that's magic. But it actually goes further, because you can fold the figure of the circle in the square on its symmetries, right? Down to get like tiles that you could tessellate to reproduce the original figure. And as long as you're folding it in that way and getting tiles that you can tessellate to get the original figure back, they retain this property, right? Where the area is related to, of the section of the circle, is related to the area of the section of the square that's preserved by this pi on 4 relationship. So when we have this square quartering the circle, the relationship between the part of the circle that's in there to the square itself is pi on 4. Okay? So we know that the side length of the square is 4. So, thus, the area of square, god damn it, is 16, right? Or 4 by 4, right? And because of this relationship, the area of, what do we call this? Sector, I guess, is that times pi on 4, but one of the 4's are going to cancel, so we're just going to get 4 pi, right? Okay, so that's where this is coming from. Let's put this in there just to make it a little more consistent in my notation. So it should be like that, I guess. Okay, so this is like, at this point, these are things that you should just pretty much automatically see based on the figure, if you know what you're doing. If we're going beyond just looking at the possible answers, if you have a decent background in this you should all just pretty much know right off the bat. Because if the side length is 4 and it's a square, you should just recognize, oh, well, the area of the square is going to be this. Right? The area of the sector is going to be this. So it's not very much of a stretch to say that the area of the, like, the weird shape, I don't know what to call it, maybe a lune, crescent, is so yeah, it's the part of the square that's not covered by the circle, is going to be the square minus the sector. Wow, I can't type for shit. Which is 16 minus 4 pi. Hey, look at that. It's probably C. And what he did, because he doesn't know this, he went through the classic circle rigmarole, which is a pain in the fucking ass, of going through all of the, like, and it actually took as long as my whole explanation just did. It was that painful. But my whole explanation there was just giving you background, because nobody's taught you that. So I'm just catching you up. I'm just getting you up to a bare minimum where you can actually understand what the hell is going on. But once you have that, you should see all this pretty much instantly. Right? This should take you maybe 2 seconds in your head, 3 seconds if you're halfway asleep, 4 seconds if you're not really paying attention. And this should take you about 1 or 2 seconds. So you've done it 2 different ways and you came to the same answer. It's probably C. That's what I'm saying. Like, these guys, they're not showing you the right way to do it. They're not showing you what you should really be doing on a test. And they're not even showing you the knowledge that you really should have in order to do these problems in real life. If you were to do this sort of thing in real life, you're going to actually quickly recognize that this is the value that you want to work with, right? Like, I have handbooks for, like, engineers where it's got tables of these, where it's got fundamental shape constants. There's ones for pentagons and heptagons and like all kinds of crazy shit. The one for a circle is pi on 4, right? The one for a triangle is 1/2, right? And this does extend to solids, right? So the one for a pyramid is 1/3. And the one for a cone is, guess what? Pi on 12, which is 1/3 of pi on 4, because it is both a pyramid and it has a base that's a circle. So you just multiply those two constants together and you get pi on 12. So yeah, there's a perfect example, a real example of what I was saying in another video where I made up, where the answers, like, you could see obviously from just looking at the answers what the actual answer is. This was a real example of one where that would have worked perfectly. It gets you the correct answer, because 4 pi in both of them, 16 minus in both of them. Here, if I do it like this, will it highlight it now? Yeah. Yeah, that 16 minus is in both of them. And the 4 pi is in both of them. Is in two of the answers. So the full answer has both of those components. Doop doop, right there. All right. 4 pi occurs twice. 16 minus occurs twice. 16 minus 4 pi is where those converge. And when we do the math, we get it up here. So, yes, the things I'm telling you are real. I'm not just being a dick. I'm not being weird. I'm not being, I'm telling you real things.